In today's lesson, we're going to look at the three basic trigonometric ratios, sine, cosine, and tangent. So first, let's look at sine of theta. Sine of theta, you look at the angle and you find the side, the leg opposite the angle given, and then you find the hypotenuse, the side opposite the right angle, and you divide the two. So sine is equal to an opposite side divided by hypotenuse. The second trigonometric ratio that we're looking at will be cosine of theta. Again, starting with angle theta, to find cosine of theta, you find the adjacent side, so that's the leg adjacent to the angle you're looking at, divided by the hypotenuse, the side opposite the right angle. The third trigonometric ratio we'll be talking about today is called the tangent, or tangent of theta. This is found by taking the side opposite theta divided by the side adjacent to theta. So it's the two legs, opposite divided by adjacent. And those are the three basic trigonometric ratios. You need to memorize these ratios. They will not be given to you. One way to help you memorize it is something called SOHCAHTOA. S-O-H, which stands for sine is equal to opposite over hypotenuse. C-A-H, cosine is equal to adjacent over hypotenuse. T-O-A, tangent is equal to opposite over adjacent. Well, you can come up with your own way to memorizing these, but you do need to memorize these three ratios. One way to help you remember tangent of theta is there is something called the tangent identity, and it says that tangent of theta is equal to the sine of theta divided by the cosine of theta. Now let's prove this to you. I'm going to do sine divided by cosine, and when I finish it, I should end up with opposite over adjacent. So let's see how this works out. So we know tangent of theta is equal to sine of theta, and we know sine of theta by up here is opposite over hypotenuse, divided by cosine of theta, which is adjacent divided by hypotenuse. And so I got a fraction divided by fraction, so I flip the bottom fraction and multiply. Simplifying, the hypotenuse cancel each other out, so I end up with opposite over adjacent. So tangent of theta is opposite side over the adjacent side. In our first example, we want to find, for the following triangle, we want to find, for part A, sine of theta. So sine of theta, recall that sine is equal to opposite divided by hypotenuse. So we look at our given triangle and identify our theta angle. Once we find theta, we find the leg opposite that angle. That will give us our opposite side, so in this case it's B. And then opposite the right angle is always our hypotenuse. So our answer is B divided by C. For example B, we're asked to find the cosine of phi. So first we go to our triangle and we identify the phi angle. And we know that cosine is adjacent over hypotenuse. So this leg adjacent to phi is the leg B, and the side, the hypotenuse is still C. So cosine of phi is also B over C. C, we're asked to find tangent of theta, so we're back to the theta angle. So we call that tangent is found by finding the opposite over the adjacent side. So back to our diagram, looking at angle theta, we notice that our opposite side is B and our adjacent side is A. So tangent of theta is B divided by A. Now our basic trigonometric ratios, let's look at how to find missing sides. Now to do this, you need to use some previous knowledge such that all the angles of a triangle add up to equal 180 degrees, and then we can use trigonometry to find missing sides. This is a three-step process. Step one, we want to redraw the figure and mark on it the hypotenuse, the opposite, and the adjacent side relative to the angle given. Then step two, we want to choose the correct trigonometric ratio to use and set up an equation. And three, we're going to solve that equation for the unknown variable. So example number one, find the unknown length of the following triangles. So let's look at A. We're given this angle of 61 degrees. So the side opposite that angle is called our opposite side. And then the side opposite the right angle is called the hypotenuse. So we want to know what trigonometric function involves opposite over hypotenuse, the side given and the side we want to find. Well, we know that's sine. So sine of 61 degrees is equal to our opposite side, which is x, over our hypotenuse, which is 9.6. So we want to get x by itself, so we're going to start by multiplying each side by 9.6, and that will give us x. Now this is the section that we're going to have to use our calculator for. Make sure that you're in degree mode when you set up your calculator. And then all I'm going to do is punch in 9.6 times the sine of 61 degrees and push enter. And I get 8.40. And then we look at our units of measurement, so our length is measured in centimeters. So my answer will be x is about 8.4 centimeters long. Now let's look at example B. Now, we got 41 degrees, and then the side opposite that 41 degrees, or the leg opposite it, is at 7.8, so we label it opposite. And then the x is the leg adjacent to the 41 degrees. So which trig function involves opposite of adjacent? Well, that's tangent of 41 degrees is equal to my opposite side, which is 7.8, divided by my adjacent side, which is x. So I want to solve for x. So first I need to multiply each side by x, so I can move the x to the numerator. And then I'm going to divide each side by tangent of 41 degrees to get x by itself. And again, I'm going to punch this into my calculator, making sure I'm in degree mode, and I end up with x is approximately 8.97, and my units of measurement is meters in this case. So x is approximately 8.97 meters long. Third type of problem we're going to look at today is finding the angles of a right triangle. Now, in order to do this, we need to use something called inverse trig functions. And I'll teach this by example. Let's say I know that the sine of theta is equal to 3/5. And I want to find the measurement of angle theta. In order to do this, we use our inverse trig function. And this is read, the angle whose sine is 3/5. Basic notations for the angle whose sine is 3/5. One notation is ARC-SIN, which is angle whose sine is 3/5 equals theta. The second notation is SIN to the -1 of 3/5. This is also read, the angle whose sine is 3/5 equals theta. Be very careful that you always read this as 3/5, as the angle whose sine is 3/5. Now, the sine to the -1 notation is used by your calculator and by your textbook. Arc sine is usually used in upper level mathematics courses. So I want you to be familiar with both notations. But we will be using the second notation most of the time in this class. Important note, always, always, always make sure your calculator is in degree mode before solving any problems in this section. So let's solve this. Let's figure out the angle whose sine is 3/5. So I punch this into my calculator and I get a decimal value, and I'm going to round it to one decimal place, and I get the angle theta must be equal to 36.9 degrees. So let's see this in action. Find the measure of the angle marked theta in each example. So first, start by identifying the two sides we're given. We're given the side opposite and the side adjacent, in which trig function involves opposite and over adjacent, which is our tangent function. So we would say tangent of theta is equal to our opposite side, which is 4, over our adjacent side, which is 7. Then we convert this to our inverse trig function. The angle whose tangent is 4/5 is theta. Theta is approximately, punching that into our calculator, 29.7 degrees. Part B, here's theta, and we know this is the side adjacent, and this is our hypotenuse. So we ask ourselves which trig function involves the adjacent side over the hypotenuse, and that is cosine. So cosine of theta is equal to our adjacent side, which is 2.67, divided by our hypotenuse of 5.92. Using our inverse trig functions, this is the angle whose cosine is 2.67 divided by 5.92, and that's equal to theta. So theta is approximately, punching this into my calculator, 63.2 degrees.